Okay, I have always wanted to work with the operation of heat pumps in district heating networks, especially in combination with thermal storage and optimization of the operation according to the electricity price and weather forecast. If you're also interested in that, the good news is I made a small web app just to do exactly that. Okay, the app is deployed on the Numos platform as a public app, and you will find it over here called Heat Pump Operator. And to use the app, simply click the button here and it will open up the app. The first page is a welcoming page which shows some text about the app, and then you have pages up here which basically leads you through the app. You can change the theme here if you want some other colors or some other theme, and you can also change the color or the dark mode and the light mode here if you wish to do that. The first page is the default page where you can change the sink and source temperatures in and out. You can do that by dragging these sliders, and if you want to do a little bit variation along the daily profile, you can play around with these amplitudes here, and you can see that you can change them. If it's 0, it's just a constant. So you can basically generate some daily profiles using this. It's for the sink and source temperatures, and it's also for the heat demand and for the electricity price. The next page is the upload page, first thing it shows is basically your default profiles from the page before. You can download those as a CSV file, and then you can basically modify it and you can upload it again. When you do that, you will see the uploaded profiles as well as a table, and you can browse the data like this. Next page is the live page. Here you can select an ambient location corresponding to a weather station in Denmark. You can also click on the map and find a weather station on the map, and it will basically give you the temperature forecast and the temperature history, and it will also give you the spot prices in Denmark at that location. On top of that, you can enter constant grid tariff and taxes, and that will basically give you a total price, and I have to move myself over here so you can see that, the total price over here. And then you can choose to use the temperature at the weather station as the source inlet. You see there's 2 dates here on the graph, and you can select today or tomorrow. You can select if it's the default data or the uploaded data from previous that you extend from. You can choose to only use the spot prices and not substitute the source temperature by the ambient temperature. In this case, I will just take the ambient temperature and substitute both source and the total price. The next page is the design page. So here is where you will design your heat pump. You can choose refrigerant here, and you can use these sliders here. You can change the temperatures, and you can even go transcritical if you want to do that. I will move myself over here so you can see the temperature profiles as well, like this. And you can choose a capacity here. So what this calculation does, it basically designs your heat pump, and it gives you a maximum volume flow through the compressors, which basically gives you how much you can deliver in terms of heat at a specific hour during the optimization and simulations. Next page is the final page is the results page. So this is where you get the optimization along the day, and you can see where the thermal storage is charged and where it's decharged and where it's charged again. You can enter how big the charge is and the initial charge. It works like this, that you always end up with the same initial charge in the end. So if it's 50%, you will end up with 50% in the end as well. So what's happening now is that it's charging during the first hour of the day, during the night, and then it's decharging in the middle of the day where the price is the highest in this simple case here with the default profiles, and then it's heating up again or charging again the thermal storage at the evening. Let's go to the live profiles, which is a little bit more interesting. The wet curve here shows the electricity price, and it shows here where it's highest. Of course, it's better to use the thermal storage. Also here it's high, so it's better to use the thermal storage. Therefore, the capacity of that goes down. And you can see the operation of the heat pump here. It's the gray one here. You can see when the signal goes 1, then it means it's using the heat pump 100%. Yeah, it's basically using the heat pump when the price is the lowest, so that's here and here and here, and then when the price is the highest, we don't use the heat pump at all. So that's what you can see. You can see heat flow rates also in the system, and temperatures in the storage and in the sink and the supply. You can see the total power that is used by the heat pump and the total cost. So in this case, with a buffer of 1000 kilo, we have a cost of 93 in this case. If we put it down to a very small number, it basically means that the thermal storage is not there, and you can see now it's increased to 112. So that is a significant benefit you can get with using a thermal storage. And we can put the size up a little bit, and we can see that it actually, there's more to save here. That's it. Thank you for watching. Feel free to comment the video or reach out to me on LinkedIn.